Hi, Devina. Welcome to our session. And first of all, thank you for enrolling a practice session with us. And yeah, so before we jump on to the actual questions, just would like to talk about session this picture here. Like most of the FRM student thinks that this is kind of you can think of the screw that you see. Bit of philosophy. Bear with me for a minute. Uh, this is something which are like questions in FRM exam. Like most of the students try to deal screw with a wrench, which is like a wrong tool to tackle this. So the right tool, like see, this comes with the experience that what's the right approach, what's the right content. That's where like we are different from like other prep providers. So without wasting much time, I just would like to welcome on behalf of Finuture Education, and like I would request to I mean I request that keep the session interactive and engaging so that you get best out of it. And yeah, we would like to start with your introduction. First, tell me how are you, and like just bit about yourself, and then we'll kick off the session.
Um, Hi, so I'm doing very well. Thank you for asking. My name is Davina. Um, I have an undergrad degree in engineering, electrical engineering, and then a master's degree in power electronics. And then from there, I transitioned into finance, and I work as a risk analyst. I'm taking my FRM exam hopefully in November, so I'm hoping this session would be really helpful.
Great, fantastic. Yeah, I mean, we also come across many people who are like blend of engineering as well as finance. Like we have like people who are good in applying things. Like finance is also an area wherein like you can apply whatever stuff that you learn during engineering. So yeah, best choice, and good luck to you for your exam. And I mean, we wish that you get through in first attempt itself. So without wasting much time, let's start. So yeah, I mean, this is just just to not you make you scared, but like this is something like one wrong tick can cost you $10. So like yeah, just m- prepare well, and have the consistent and focus and studies so that we are like on track. So let's start. And any of the topics that you might not have read, I'll give you the full context so that you are in a position to relate. And so, yeah, I'll give you the context if any of the topics that you may encounter are like you're not done with reading of those. So, there is an analyst who's concerned with the symmetry and peakness. So, the first keywords I would like to highlight, like when we talk here about symmetry, it's skewness that's mainly preferred, and when we talk about peakness, largely it is kurtosis. But kurtosis, just keep in mind that kurtosis is also referred to tails also. Like if your tails are thinner, fatter, so it's both. Peakness is like when we talk about distribution. Usually, it's the peak of this mountain that is referred to the peak, like kurtosis. But sometimes, like when your peak is little higher, so your tend to become thinner. So, like that kind of uh, that kind of distribution is called as leptokurtic, which has excess kurtosis, but they have thinner tails. Likewise, you can think of some distribution which has like uh, the less peak, but
So normal distribution would be mesokurtic, and then
yeah,
platykurtic would be like when it's
it's less than, it's like, see, there are two things that are usually talked about when we talk about kurtosis. For normal distribution, it is three. So for normal distribution, the kurtosis is 3. And usually there is something which is also referred in context of weakness, that is excess kurtosis. So when we talk about excess kurtosis, it is usually K minus 3. We are trying, this is kind of a relative measurement of kurtosis. We try to measure with respect to normal distribution. So minus 3. So if
Mm.
I substitute this K from normal distribution here, so I can say that there is no excess kurtosis for normal distribution. Does it make sense?
Yes, yes.
And and likewise, can you tell me what if I can comment about excess kurtosis of leptokurtic and platykurtic? Like if I,
So,
yeah.
so if it's leptokurtic, the distribution, the kurtosis would be
Mm-hmm.
more than 3. So
Perfect.
there'll be excess kurtosis.
Perfect.
But like in platykurtic, it will be less than 3, so there will not be excess kurtosis.
So yeah, whatever you just said, I'll just write in the notation form. For leptokurtic, kurtosis is greater than 3. For platykurtic, kurtosis is less than 3. For normal distribution, kurtosis is equal to 3. So this is about kurtosis. Can I comment something about excess kurtosis? Let me write EK. There's no term like usually we denote it with the full letters, but just for understanding, if I were to write something about excess kurtosis of these, what can I write something?
It would be K minus 3.
Yeah, it would be K minus 3. So in this case, the normal distribution has excess kurtosis 0. If my K is greater than 3, so this excess kurtosis would be positive. Agree? Like if
Yes.
so, if I am substituting K something which is greater than 3, so this would be positive. That means it would be greater than 0. For platykurtic, this is less than 0. Does it make
Yeah.
sense? Just the background or context of kurtosis. Um, Skewness, it is like it's quite like evident, like it's quite straightforward, unlike kurtosis, which is a bit tricky. So if I just talk about normal distribution, this is like skewness is a measurement of symmetry, like how
Hmm.
symmetric your distribution is. So if
For
your
normal distribution, it would
Mhm.
be equal to the mean, right? Like it's essentially equally distributed around the mean.
Yeah, so for normal distribution, your mean, median, and mode are equal. Like when we say
Yeah.
these are just measurement of like these are just parameters to measure your data.
Mm-hmm.
So like we say that skewness is 0 because these are symmetric. There is no like inclination towards right or left. So we say that skewness is 0. And if I just talk about say like this, some distribution like this. So for this one, like this is called as positive skewness because you have tell on the right hand side, and
Yeah.
what happens that when you have tell on right hand side, any guesses where your mean will get
The
shifted?
mean would be bigger than the median, and the median would be bigger than the mode.
Yes, perfect. So wherever your tail is, like your mean gets shifted toward that side. So for this one, we have mean on the right hand side. Median is always in between. And wherever like mode would be, like wherever your tail gets shifted, your mean will get shifted. You can accordingly name rest to like the the number one criteria is mean gets shifted towards the tail. Median is in always in center. Like whatever is
Mhm.
the main, you can just uh tag that as a mode. So let's look at the question, like just the context of these two terms I gave you. For return over period of time for company she is examining, so analyst is examining, and she has returned distribution of the data. She does some calculations and find the median is 4.2%, mean is 4.8%, and mode is 3.7%. So if I were to write uh relation, so let me see that where the median is, sorry, mean is highest. So I can
Yeah.
say that mean would be on the right hand side. So mean is like it's greater than. So
Yeah.
mean is greater than whatever the followed by your median. Median would be always in between. So 3.7%. So exactly same situation like
It would
3.7%. Yeah.
it would be the other way, right? the greater than sign would be that it will point the other way.
Yeah. Sorry. Yeah, this is 3.7 is less than this one, and 4.2 is less than this, and so mode is less than median and less than mean. So
Mean.
essentially, your mean is highest. That means your
Mhm.
mean got shifted towards the right hand side. So now, what you have to so this is about skewness. She also finds as measure of excess kurtosis is 2. So you're given. Now be very careful. This is excess kurtosis, not really kurtosis.
Yeah.
So
Okay, good to
excess
know.
kurtosis is 2. Based on this information, what is the
Yeah.
correct characterization of the distribution? Would you like to
So
try?
based on this, since the mean is greater than the median, greater than the mode, this has to be positive skewness. And because we have excess kurtosis, that is only possible for a leptokurtic case. So it would be option A.
Perfect. So let me make it a bit tricky for you if you can try. If instead of excess kurtosis, had this been just kurtosis? 2.
In that case, it would have been platykurtic because your kurtosis is then less than 3.
Yes. So what would have been the right answer for that?
That would have been B.
B. Perfect. Fantastic. Let's move ahead. So that was first question, the easier one. So this is something what we already discussed, but
Yep.
just in case if you want it for reference. And this one is little like, of course, the earlier one was also like an exam level question. This one is also kind of that level question. So there is a credit risk manager who is in charge of credit risk analysis of large corporate at Bank XYZ. So there is a credit risk manager at Bank XYZ. The manager is in a position of credit rating provided by two rating agencies, X and Y, for 30 companies. So basically, credit risk manager would always be keen to obtain great credit rating from rating agencies. So they obtain credit ratings for 30 companies from two rating agencies, which are X and Y. The ratings are classified into four categories. So it's a categorization of the credit rating. So one, two, three, four. And one means that high investment grade, two is mid investment grade, three is low investment grade, fourth is non-investment grade. So I think they missed to ask question. So the question here is like which kind of correlation should be taken into account. So just to give you context, like usually when we talk about correlation
Mhm.
in quants, it is usually Pearson correlation that we talk about, and that is measured using this formula, which is covariance of y over variance of x and y. So this is your normal correlation formula.
Yeah.
Essentially, what it does give you, it gives you the if there is a linear relationship between given variables. So,
Okay.
like one can ask, what if my variables are not linear, something like this over here? Like if I were to plot, this is a plot from Python or just a random four forms, like this could be 30, we can all go all the way till 30, but just in case if one has to visualize what exactly is happening, so one can ask what can happen if your data is not linear, if your data is like something like this classification or categorization of your data set. Like if I were to talk about this firm out of 30 companies, so in this particular blue dot that you see, for this one, rating agency X is also rated that as high investment grade, and rating agency Y also has rated that company as high investment grade. So that kind of stuff, if you have that kind of stuff, what is the right correlation measurement? So for that, we have got ordinal, like usually we talk about two correlations there. One is Spearman and another one is Kendall-Taub. Those are something which helps you measuring correlation for non-linear data, or you can say wherein you have got orders like this or classification like this. So like earlier this was like it was a part of level 2 syllabus. Now they have just brought this into the level 1 curriculum. So like yeah, so these are the correlation. I think we are yet to do this topic, but yeah, these are the correlations that we talk about, like Spearman and Kendall-Tau. So these are used to measure the ordinal data, the correlation in ordinal data. So is that making sense? Like general, of course, the formula, other things we can just show it to you, very holistic view. But in general, is it making sense?
Yeah. So
Okay.
basically, Pearson correlation is relevant if it's linear data,
Yeah.
but Spearman correlation is relevant if it's ordinal data.
Ordinal, yeah, ordinal, or you have got classification, like wherever you classify your data. So that's where your Spearsman and Kendall-Tau both are used to measure ordinal data. Okay, and when you have got linear data, like your variables are linear in nature. Like when we talk about stock and index return, then we talk about Pearson correlation. And sometimes like this kind of data where you got classification, we talk about Spearman or Kendall-Tau. Okay.
Okay.
And like yeah, for the continuous one, there are others also. Like you may come across in your valuation and risk models also at instances, not that intensively as intense in your level two, but there are like other themes also, correlation matrix, covariance. These all are for continuous data. Wherever you got ordinal data, you will use Spearman or Spearman and Kendall-Tau. The Pearson, like the names are like when we pronounce, it's quite like it may appear similar, but this one is for linear and these are for ordinal. So I'll just mark this because I know like uh, it's one option that's quite trivial. So let me keep the trivial or simpler question for me. I'll pass on the tougher ones to you. Okay.
Okay.
Let's move ahead. So this is a formula. Like if you are keen, like of course in this question, like someone might be interested that how do I calculate Spearman correlation for this data? But for that, we will need 30 companies rating. What are their respective provided ratings? So we can calculate. But for understanding, just think that for returns also, you can calculate Spearman also. It's not really, see, once that you can measure using Pearson, you can always calculate for Candle Tau and Spearman. But other way around is not true. For this data, like for this data, I cannot calculate PSN because how will I calculate? How do I calculate covariance? So that becomes pretty challenging because for ordinal data, calculating mean and distance from mean, like you need deviation. When you say covariance, what is it? It is actually x minus mu and x minus mu x, y minus mu y, multiplication of that over n minus 1. So that's the correlation. And same goes with x standard deviation. X minus mu x you will require mu x y minus mu I, yi minus mu y. So calculating average over here is bit of challenge. That's where like the point I'm trying to make over here is for linear data, you can always calculate something Spearman and Kendall-Tau. Like this is a classic example wherein you are given two returns, and what you do, like I'm just for your benefit, I'm just giving you the steps. Like for say X returns, you arrange it in a ascending order. Like you can see that like minus 20, like sorry, it's yeah ascending. So it's up to you, like you can always do ascending or descending, that's purely your choice, but ensure that whatever you're doing with x, same you do with y. So for y, the minus 20 was lowest, followed by minus 10, 20, 40. Same I do with for my variable y. And once I have done that, what I can do, I can rank. So that's where the order will come into the picture. You rank, this was the lowest. For X, this was the lowest. So 1, 2, 3, 4, 5. But now what I'll see, for wherever it was rank 1, for minus 20, what is the rank of Y variable? So Y variable will also Like if I were to check y variable, it's ideally minus 20 should have been at top. Agree?
Yeah,
No?
because it's one. Yeah.
Yeah. So for this one, I think it is also one. So ideally it should be one. So I'm just telling you these steps. I can just tell you back because it is from live session. So it should be one. So you calculate difference between the rankings. So what is the ranking of X and ranking of Y? You calculate difference, square it, and you have got direct formula like 6 summation di square. So this is when I say di, it is difference between the rankings over n upon n square minus 1. Subtract this quantity from 1. That is your Spearman correlation. So this is how you like calculate. So you can just square it. Like for this one, it would be 0. Then let's check what should be the ranking of 30. So ranking of 30 is 4. It is highest one amongst the y variables. So we have
Hmm.
written 4. So 2 minus 4 is 2. Square of that is 4, di square. Ideally, this should have been 0. Otherwise, I think we are good. So this is how you calculate Spearman correlation. For our example, where we have got 30 companies, uh, we can always just arrange the data for, say, for this is the first company. What was the rating of X and what was the rating of Y? We can always do that and we can calculate the difference between that. Is that making sense?
Yeah.
For continuous one, you have to rank. For this one, I think they have already like for first company, it's a first company. Just calculate the difference. Some the difference square and substitute in the formula, get the Spearman correlation.
Is this like on the exam? Are we required to calculate?
Yes. Like yeah, in fact, it's a low hanging fruit. I would encourage you to like the data would be not that big, like 30 data points. When you have got such a big data point, the question would be like this. In fact, it's much easier to just identify which correlation type it is. But if you are asked to calculate the correlation, then data set would be like this, like just 3, 4 data points, and you just have to consider the differences. And in fact, I would say that this one is little more trickier. The one that we talked about, Candle Tower. I'll not go into that detail, but we can always talk about that in live classes. So this is like you have to create pairs, which are concordant and discordants, divide by n upon n minus 1 over 2. That's the Candle Tower, the another ordinal correlation measure that I talked about. First one is Spearman, second one is Candle Tower.
Okay.
This one I'll cover that during the live classes, so just rest assured. But because this will take little longer time, and I just need to ensure that I give you flavor of more questions. So, but yeah, we can always cover this during our classes.
Thank you.
Okay. Yeah. This is I deliberately kept it blank if we need for working. This one is bit interesting, and just allow me a moment. So let's move to another one, the most trickiest one, I would say, from this session, because many people find like if I were to break down entire quants in like very high level subsections, I would say probability, basics, and some bit of like distributions that we study. Second one is hypothesis testing. Third one is like regression. Fourth one is this bit, which is time series one, and the last one is machine learning. That's how like it is this categorized. I think you can also categorize for your convenience to do a preparation. So this falls under the time series, which many people find it toughest. So before I touch upon this question, I would just give you the context, what these terms are, and so that you are in a position to break down the question. And so if I just talk about let's read question first, then I can give you the context as and when we come across the terms. Market risk manager would like to analyze and forecast security performance and has obtained the historical time series data. So there is a market risk manager, like perhaps the return. This I would think that this is a returns time series data. The manager consult a colleague from quant analytics team to who provides the following partial autocorrelation plot. Based on the plot, which of the following is best regression approach for the security? So see, in fact, the questions like this will appear very fancy or like super complex. In fact, those are the ones which can get you the easy marks. I would say that's what my experience has been. So let's study a few terms. Like one is autocorrelation. So when we say auto, it's with itself. So when you are talking about autocorrelation of returns time series, so it is a correlation of today's return with the prior day return. Like if I were to collect data, it's like YT minus one. When I say YT, it's today's data. So like if I just call yesterday's Friday as today, like just imagine it was YT's today. So that would be I would say one, like, or let's call that as zero, where we are standing currently. So this is your Friday data, this is your Thursday data. If I go one day back to Thursday. So this is on Thursday, this YT is Thursday data, this is Wednesday data. You can go on and on. You can collect your entire year data, 252, say a year back on August 18, 2023. This was your returns and the prior day returns were these. So if you calculate the correlation between these, like you can notice on first one usually it is taken with Friday because that's why you see one. The first auto correlation is one because usually it is like zero with zero. Then you can start with this like Friday versus Thursday, and you can always calculate the correlation between this data and this data. So that's how the correlation is plotted for various time periods. So that's the autocorrelation. Now, partial autocorrelation is little trickier. For this one, for this one, I have used the daily data to come up with a correlation for 1 year. So instead of this, if I just use, say, yesterday, Friday, that is August 18, 2024, if I don't use in between data sets, and if I directly go back to my prior data, like that is 1 year back data, and if I calculate the correlation, if I collect data in that manner instead of daily, if I decide some lag variable, say my lag is k, it could be 1 year, 1 month. So if I'm just using instead of daily data, if I'm making it monthly data, so if I'm instead of Jan, I directly take Feb, like in Jan directly data, I can take January versus February. That is something which is a partial autocorrelation. It will like somewhere see what can happen. I can study this 250 correlation you collecting daily data also. I can make a subset of monthly data, but to some extent, why we call it a partial? Because some kind of noise would be like suppressed when you calculate the partial autocorrelation. So like autocorrelation or partial autocorrelation, these are the two terms. Is understanding clear or any doubts in this autocorrelation, partial autocorrelation?
So with autocorrelation, we have to use data, which is collected on a daily basis, and it's correlated to itself um,
Uh,
from one
like
day to the next day.
yes. So for this case, you can say daily one, but say for example, like I would say that this is a minimum any kind of data. Say for example, there would be some data which is just available yearly. There is no daily data. So if I'm using that entire data, then that would fall under the autocorrelation. But in this case, when I have just yearly data, if I'm just deciding one decade, January, say 2024 versus January 2020, 2014. So it's in autocorrelation, it is a minimum unit that you consider. For stock returns, I may have a daily return, but close of business is just a daily returns that is available. So Are you following? Like it's a bit tricky.
Yeah, no, I understand. So basically, in partial autocorrelation, you skip over some data. Is that
Yes.
correct? And
Perfect.
that's why
Perfect.
that suppresses some noise. So basically, you don't even include the whole data set.
Perfect. Yeah. Perfect. Yeah. So when you include entire one and you come up with something, that is autocorrelation.
Okay.
Okay. So like we are asked that which one of the below is the best suit for these plots. So I would now I explained you two terms, that is autocorrelation and partial autocorrelation. Now there are two more terms. One is AR, one is MA. So when I say AR, it is auto regression, and when I say moving average, it is like MA, it is moving average. So when I say auto regression, as name suggests, that it is regressing today's value from yesterday's value. So what you do, you give some weight, there would be some coefficient, like, or the mean also can be one of the coefficient, like this could be anything. And there would be, or let me call, because I think, like, just check the convention in the book, there would be some multiplication, just one term plus some coefficient times your priority data. So what you do, you try to regress your today's return from the past day returns. There would be some coefficient. It's not really that whatever was yesterday, it will happen today. So this, you try to come up with some multiplier or coefficient which you can use to predict today's return. So that's the auto regression. So for auto regression, you use the prior day value of the variable. Is that clear for auto regression?
Yeah.
So that what I explained is AR1. So similarly, if I talk about AR2, that is auto regression using two past variables. So if I'm trying to regress to YT using YT minus 1 and YT minus 2, then that is auto regression. Is that clear? Like you can always
Yeah.
talk.
So basically, you have to go back 2 days. So let's say I'm
Yes.
talking about today's data. I'll go back. Let's say today's Friday. Then you would go back to Thursday, and then you'd also go back to Wednesday.
Yes. So like the lagged, like you can always talk about ARQ, wherein you will go Q days back to
Hmm.
regress today's value. Okay. Now, moving on to moving average. So if I talk about moving average, it is quite similar to this one. The only difference being, instead of using 1 day lag value, you use 1 day lag shock. So when I say shock, it is like you can just see, just check the notation for this in book, but it is something plus, like how we have a equation of linear line, it is mx plus c. So c, this c would be there. There would be some constant plus impact of x variable. In this case, our x variable was the priority return. We were trying to regress y. So for moving average, it would be something plus your phi times your shock. So epsilon t. So when I say shock, it is not really a priority value, but there would be, see, if I just talk about this data, there would be, these are returns. So suddenly something like COVID came. So your return data will go down like this. Okay. So this
Yeah.
is a shock that you use to predict today's value. That is called as a moving average. So if you use one lag shock, then you talk about MA1. If there was some, say, not immediately recollecting before COVID, any event that you can recollect, I can just, like the some with a very high intensity. Anything that comes.
2007 to 2007, 2009 financial crisis.
Yeah, that's in fact super intense. So if you include those two to regress, like of course, like for this one, there are some shocks with the lower intensities are also considered in practice. But for sake of understanding, just think that if that is one leg shock, if you go till so this is moving average one. If I include two shocks, then it would be moving average two. So basically, the driver of today's returns in AR1 is your lagged returns, and this one, these are lag shocks.
Yeah.
Is that clear? So now you are asked that you have this kind of plots. You are asked that from this, what you can interpret that what kind of this data is. So see what happens that when you use a shock to predict, like moving average to predict, what will happen, like when you predict today's value, perhaps it from the past shock, it would be like very big because you have included the shock. It would be too negative or too positive. Say, for example, I regressed to YT, today's return from some past shock, so it would be too higher. And if I consider uh, same for next day, because impact of this would be there in this case also. Say, for example, I use the moving average. Now I'm going back to AR. So if I go A to AR, impact of this would be here because I had regressed it, but uh, ignore, because in practice that may or may not happen, because there are instances wherein when you regress today's data from past shock, it may give you the good precision, like your implied data would be quite near to you, but that is very subjective. Like when you have to do that, usually it is this one that you have to use, but from plot, how do you justify? So if so when you get such type of question, purely from exam point of view, you refer to this one. And from this one also, you can see that your data is quite decent. Auto correlation, your data is quite stable. So you have used AR, because if you use MA, you may have initially you may have a big sticks, then it would be quite consistent, because over here it is quite stable. So we can say that it is auto regressive. But how do I interpret if it is auto regressive one or two? So for that, so is that clear that from auto correlation, I'm interpreting that my model is auto regressive because it's quite stable. It is not really, there are no spikes in the auto correlation data.
Yeah.
I can conclude that it is auto regression. To conclude, if it is one or two, I will look at the partial autocorrelation graph. And if you notice, after two sticks, it has dropped. So it is AR2. Because after that, there is like it's quite stable. So you can see that the impact of, say, 2 years, if I have used, say, yearly data, in this one, so impact of this would be passed on till here only. After that, I think this would be a real implied data, so it may diminish. So after two, it has quite gone down to lower side, so you can say that it is AR2. So the thumb rule is that you have to look at autocorrelation to decide whether it is AR or MA. Then you can go to partial autocorrelation to conclude one or two. So use this one to conclude it is one or two, like what how many lagged variables or shocks are used. To conclude if it is AR or MA, you can always use the autocorrelation graph. That's how, like,
So
yeah.
how would it look if it was AR1?
Uh, AR1, you would see that after this only, like it would be a, like some stick like this would have been here, because there are two sticks. You can say that the impact of like two legged variable was here, but after that it got diminished.
So after one stick.
Yes. So if I were to plot partial autocorrelation graph, only I have to reduce the size of this stick. It's somewhere like till this, or like somewhere like I can plot something like this after one stick only. So partial autocorrelation is also like in the boundary after one stick. This one stick would be outlier, and the rest of the sticks in the partial autocorrelation would be in the range for AR1.
Okay, I see. And if it was MA, like moving average, then you would see it randomly, like that spike, right?
Uh, for moving average or AR. So for AR or MA, you can refer to this graph, autocorrelation. In this
Yeah.
one, you will not get this kind of consistency. Had this been moving average, you will see the quite of step instability here. But
Mhm.
for one or two, you have to refer the partial autocorrelation graph.
Okay, so you'll again, even for MA, you'll see one spike, MA1.
Yes. Yeah.
And for MA2, you'll see two spikes somewhere.
Perfect. Yeah.
Okay.
Bit trickier, and like Like you may need some more readings to absorb this or get insight of that. But yeah, for now, I think I gave you the hints. If this kind of question you encounter in the exam, how to like break it down.
Yep.
Okay, shall we move ahead?
Yeah.
Okay, so it's AR2. So it says the PACF cuts off of the second leg. Behavior indicates the AR2 process. Now, Mark Johnson is an analyst who is studying the relationship between stock and index. The stock returns are annual standard deviation is 15%, or stock return it is 15%, and S&P 500 it is 16%. He performs a regression on stock return against the market return, discovers the following regression model. So like he collects the data, try to, like, you can always do that. Like you can uh on X, you have got index or S&P data. On Y, you have got stock data. So what you can do, you can always collect the data, daily data, and try to fit a line. What this line is like such line that your distance of each data point is lowest with this line. So he
Yeah.
arrives with that line Y equal to C plus MX, this
Yes.
kind of equation.
Mhm.
What is the correlation between stock XYZ and S&P? You can always find from this one, you can always use correlation. For correlation, as I said that over here, we will talk about which correlation, Pearson or Spearman, Pearson or
Pearson.
Pearson.
Pearson,
Yeah.
because it's linear,
Yeah. So it is covariance of XY over standard
divided
deviation
by,
of
yeah.
X and Y. So I need basically covariance to
Yeah.
calculate correlation. Otherwise, standard deviation of both are given, X and Y.
Yeah.
So, so I need, this is already I have, this is something I have to calculate. So how do I calculate? So, there is one term called as a beta, which is market sensitivity. Basically, what it measures, if your index moves by 1%, how much percentage move can be in Y? So that's the slope, in fact. So that is beta 0.82 we are given, and so that is variance of X and Y divided by the market volatility. So like this is covariance of XY. I know beta, I know standard deviation of X, that means
X.
standard deviation of your index. So you
Okay.
can just multiply. So 0.82 times what was for index?
0.16.
0.16, yeah. So 16% of 82, how much that would be? 10% is 8.2. 8.2 plus 4.1, that is 12.3. 12.3 plus 0.82. That
0.8 times 0.16. That's 0.1312.
let tell me 0.
1312.
1312. Yeah, that makes sense. So now what we'll do, we'll just substitute here. Like it would be 0.1312 over 0.15 into 0.16. Can you just help me with, if you have calci
Yeah.
handy?
Okay, wait. 0.1312 divided by 0.15 and then divided by 0.16. I'm getting 5.5. That's not correct, is it?
Mm, where did we go wrong? I think it is variance of X if I'm not mistaken. I need to check. Can you try with this one? Like just square it and then multiply.
Okay.
I think
0.82.
it will further decrease.
No, that'll increase this number, no?
Oh, okay. Yeah, it's in the denominator. Okay, yeah, that makes
Mm.
sense.
Is it 1 second?
Sure.
I
Or let
think
me, yeah.
I think so I think where we're going wrong is because the beta is covariance divided by variance, and we're taking standard deviation.
Yeah, that's what I said, Kate. If
So,
you can just
so
square it and then check.
square it and then check. Okay, so we have 0.16.
That's I think standard deviation. So if you
Yeah,
want
so
variance,
square it. Yeah, so 0.0256. So 0.82 divided by 0. Oh, sorry, my bad. 0.82 times 0.
mm-hmm. 16 square. Or
One
what you can do, you can
square.
always
Yeah,
point
yeah,
to
yeah.
1.16 square.
Zero. Yeah, so it's 0.02099.
Too low. That's what my prediction was, that it would get decreased. Let me think. What's the answer? 0.16 square times 0.82.
0.02099.
Yeah, I think that looks little reasonable. To 0.02099.
099.
Now just substitute this in the numerator of here, like divide that by,
Divide that. So I'm getting 0.875.
I think, yeah, then
So
I
the
think it
answer
should,
should be D.
yeah, let's see what is that. Yeah, I think it's
Yeah,
the
yeah.
0.875 only, exact 0.875. Perfect. So just give me a moment. So, Devin, I think we're done with 1 hour session. We can continue some other time, like as in when we can coordinate via our team. So, any closure comments from like whatever you studied, especially on this one and this one?
Yeah. So there were a lot of uh, questions that we discussed, which I wasn't fully aware of because sometimes you study, the theory and then application becomes a little harder. So this really helped me with that. I think I'm going to get deeper into some of these concepts. So it's been a great session. Thank you.
Thank you very much for your time and good luck for your exams.
Thank you.